This is the first problem. Sample problem number 1. A 900 kilograms car moving at 10 meters per second takes a turn around a circle with a radius of 25 meter. Determine the acceleration and the net force acting upon the car. So the solution of this problem begins with the identification of the known and requested information. So the known information is the mass, speed, and the r. So m is equals to 900 kilograms and b is equals to 10 meters per second and r equals to 25 meters. So the requested information is our problem. So to get the acceleration, then we must use the equation a equals b squared over r. So e equals b squared over r. Substitute the value. So a equals 10 meters per second squared divided by 25 meters, and then square the 10 meters per second, and it will be 100 meters per second divided by 25 meter, and a is equals to 4 ms, 4 meters per second. That's our acceleration, 4 meters per second. So to determine the net force acting upon the car, use the equation F net equals m times a. So the solution is as follows. So F equals m times a. So substitute the values. So F net is equals to 900 kilograms times 4. So our F net is equals to 3600 n. That's our net force. So let's go to the sample problem number 2. So a 95 kilograms halfback makes a turn on the football field. The halfback sweeps out of a path that is portion of a circle with a radius of 12 meters. The halfback makes a quarter of a turn around the circle in 2.1 seconds. Determine the speed, acceleration, and net force acting upon the halfback. So the solution of this problem begins with the identification of known and requested information. So the known information is the mass and the r. So mass is equals to 95 kilograms and the r is equals to 12 meters, the radius. So and the requested information are the speed, acceleration, and the net force. So to determine the speed of the halfback, use the equation b equals d divided by t, where the d is 1/4 of the circumference and the time is 2. So speed is equals to the distance over time, where the d is 1/4 of the circumference and the time is 2.1 seconds. The solution is as follows. So b equals d over time. Substitute the value. So b equals 0.25 times 2 times pi times r divided by time. So b is equals to 0.25 times 2 times 3.14 times 12.0 meter divided by 2.1 second. So the value of our speed, or b, is equals to 8.97 meters per second. So to determine the acceleration of the halfback, use the equation a equals b squared over r. The solution is as follows. So A equals B squared over R, then substitute the value. So we got A equals 8.97 meters per second squared over 12.0 m. A is equal to 80.5 meters per second divided by 12.0 meters. So our acceleration is 6.71 meters per second. So to determine the net force acting upon the halfback, use the equation F net equals m times A. The solution is as follows. F equals m times A is equals to F equals 95.0 kilograms times 6.71 meters per second. F net is equals to 637 N. Let's solve a simple problem. So a 1000 kilogram car moving at 10 meters per second takes a turn around a circle with a radius of 20 meters. Determine the acceleration and the net force acting upon the car. So first we'll do the identification. So the mass of the car is 1000. The speed is 10 meters per second. And the radius is 20.0 meters. So the requested info is the acceleration and the net force. So use the equation to determine the acceleration of the car. So the equation of acceleration is E equals B squared over R. So let's do this. A equals B squared over R. Substitute the values. So B is equals to 10 meters per second squared. Divide by R, which is 20.0 meters. Then the square of 10 meters per second is equals to 100 meters per second divided by 20.0 meter. So the acceleration is equals to 100 meters per second divided by 20 meters is equals to 5 meters per second. To determine the net force acting upon the car, use the equation F net equals m times A. So the solution is F net equals m times A. So substitute the values. Value of m is 1000 kilogram times the acceleration, which is 5 meters per second. So the value of F is equal to 5000 N. And that would be all.